Hi everyone, good day. Today we are going to see the next lecture in the course Cryptography and Network Security. So this course is developed by Jawaharlal Nehru Technological University, Kakinada in association with Andhra Pradesh State Council of Higher Education. The topic that we are going to cover in this lecture is Mathematics of Cryptography, that is part 2. So in the previous lecture we have covered two topics regarding Mathematics of Cryptography, that is integer arithmetic, and then what are the operations that we are going to do in the integer arithmetic, and then followed by two algorithms, that is Euclidean algorithm and extended Euclidean algorithm. The Euclidean algorithm will be helpful for us for finding the GCD of two large numbers, whereas the extended Euclidean algorithm will help us to find out GCD along with two constant values s and t, and we can consider that t as multiplied to inverse. That's what we are going to see in this finding the multiplied inverse using extended Euclidean in this video. Now in this video we are going to cover the topics regarding modular arithmetic and congruence. So what is congruence in the with respect to modular arithmetic, and then we are going to know about matrices, what are the different operations that we are going to do on the matrices, and then finally we are going to find out what are additive inverses, multiplicative inverse, and finally we are going to find out linear congruence. So let us start with modular arithmetic. Okay, right? So here the division relationship we have considered A equal to Q into N plus R. The equation that we consider Q into N plus R is discussed. So here in the division operation, we give importance to Q as well as R. We give importance to Q as well as R. So apart this is division operation, along with the division operation we'll also have another operator called as modulo operator, where we give more importance to the remainder R. We doesn't care about Q. Right? So here we doesn't care about Q, and the modulus operation that we are taking, that it deals with modulo arithmetic. Now if you observe here, by using this modulo operator we can convert this equation, that is the division operation, like this. We can convert the division operation like this. So if you observe here, we can change the above relation, that is A equal to Q into N plus R, into a binary operator with two inputs A and N and one output R. So if you observe, when you discuss during the division operation, we said that here we cannot consider this division as binary operation. We can consider, we say that A is divided by B. A is divided by B. That's okay. We can call binary operation. But when we compare with like addition, multiplication, subtraction, this will give two different outputs. That is Q and R. So we have specially taken this division operation and we have discussed, right? So we can convert this operation into normal binary operation like our addition, multiplication, where it takes two values and give output as one value. And the output was one value, and that operator that we are considering, we can call it as modulus operator, and we can represent it as mod. Okay, so this is the difference between normal division and mod operation. So if you take the input values from the set of integers j, so if you take it as A, and if you apply division operation with respect to V, so we can take A is equal to Q into 1 by R. So here we have said that A is called as dividend, N is called as divisor, and Q is called as coefficient, R is called as remainder. So it yields you two outputs Q and R, But here in the modulo operation, if you observe, we are taking A and we are only considering the value dividend, that is divisor. We are considering dividend and divisor, and we are applying the modulus operator. Then we are getting only one output, that is remainder. And we can call this remainder, instead of remainder, we call this as residue in the modulo arithmetic. We call it as what? Residue in the modulo arithmetic. In normal arithmetic, we call R as remainder. In modulo arithmetic, we call it as residue. We call it as what? Residue. For example, if you consider any two values, if you consider any generally in our languages, we represent with this operator. This is the modulus operator. If I apply modulus operation between 4 and 2, it will be 0. Why? Because there is no residue here. 2 exactly divides 4. 2 exactly divides 4. But if I take 5 and if it divide it by 2, now I can take this modulo operator here. My residue will be 1. My residue will be 1. Why? Because 2 does not exactly divide. 2 does not exactly divide. So this is how a residue is produced, and we consider that operation as mod operation, and we call that as 5 mod 2 produces residue as 1. We call it as 5 mod 2, and we represent like this. We can represent like this: 5 mod mod 2. If you apply operation mod operation between 5 and 2, what is the residue that is going to coming? It has 1. So this is how we are going to represent. So next we'll see a set of residues. Next we'll see set of residues, and we are going to represent it by using Zn. We are going to represent by using Zn. So where generally if you consider Z, that is set of integers, similarly we represent set of residues as Zn. Now what is this concept of set of residues is? For example, if you consider finding mod value with respect to n, now what are the possible residues we have? For example, like before going to that general thing, we'll consider mod 2, consider as 2. So if you apply mod operation with respect to any integer with respect to 2, if you take any integer and apply mod operation with respect to 2, it produces only 2 residues, either 0 or 1, For example, if you see, if you apply 4 mod 2, as 2 exactly divides 4, we'll get the residue as 0. If you apply 5 mod 2, we'll get residue as 1. Like that, if you take a big number also, if you take 151 mod 2, so 275 or 150, and so we get only one thing, residue is 1. So if you consider, if you take mod 2, all the values that it produces residues are 0 and 1. Okay, in the same way, if you consider mod 5, it also produces all the residues with values starting with 0, and the maximum residue value it can have is 4. So if you observe, if you take n here, the residue values or the residues that are produced when you apply mod n will be from 0 to max of n minus 1. Now all these values within this set, we call it as set of residues, and we are going to represent with a letter called as Zn. Why? Because we are applying this mod operation between the values which are belonging to the set of integers Z, and this n represents is a modulo thing. So this is how we are going to represent. So this is Z of 2, this is Z of 6, this is Z of 11. And we can say that the modulo operation creates a set. That's what I told you, which in modular arithmetic is referred to as set of least residues modulo n. So we can say this as set of residues when we apply modulo n. So these are set of residues when you apply modulo 6. Okay. Now we are going to see the next concept called as congruence. So congruence is nothing like equality. Equality. So when we are going to say two values are equal in the modular arithmetic is, when you apply a modular operation with respect to a particular value, if two integers are producing the same value, that is, if they are giving the same residue with particular modular with a particular value, then we can say those two are equal. But in modular arithmetic, this equivalence we represent by using an operator called as congruence operator. We call it as what? Congruence operator. In cryptography, generally we often use the more concept of congruence. We doesn't use more concept of equality. So generally we know how we are going to represent equal. So this is how using two dash symbols we are going to represent equal. So simply in the concept of congruence we add one more. So this will be the symbol for congruence. This will be the symbol for congruence. Now, how we are going to represent the congruence? So, for example, if you consider we are taking mod 10, you are taking mod 10. So, if you consider 2 mod 10, it produces residue 2. If you consider 12 mod 10, it produces residue 2. If you consider 22 mod 2, it produces residue 2, and so on. So, we can say that 2 is congruent equivalent to 12, is equivalent congruent equivalent to 22 with respect to mod 10. With respect to mod 10, we need to mention with which mod value those are congruent. For example, if you are not mentioned these value, if you not mention this value, consider you are not mentioned the mod value, simply if you say that 2 is congruent equivalent to 12, if you say that 2 is congruent equivalent to 12, now if I take the mod value as 3, now what happens? What is the value of 2 mod 3? 2 mod 3, the value is 2. If you apply 12 mod 3, as 3 exactly divides 12, it will be 0. Now see, the residue produced by 12 and 2 with respect to mod 3 are different. Now in this scenario, I cannot say 2 is congruent equivalent to 12. So that's why when we are representing two values are congruent equal, we also need to mention with respect to what mod value. So here 2 is congruent equivalent to 12 with respect to mod 10. Similarly, 13 is congruent equivalent to 23 with respect to mod 10. Similarly, 3 is congruent equivalent to 8 with respect to mod 5. 8 is congruent equivalent to 13 with respect to mod 5. Similarly, right? This is how we need to represent. So this congruent symbol you need to remember with these three hyphens. With these what? 3 hyphens. Okay. Okay. Now we'll move for the next topic. So if you consider here all are congruent equivalent, that is -8, 2, 12 and 20. Now how we are going to find the mod of minus value? This is what one interesting concept. This is one interesting concept. So I need to find -8 mod 10. So for positive, for example, it is 8 mod 10. If it is 8 mod 10, I can directly take it. 8 mod 10, I can get 8. Now, so if I take 10 minus that 8 minus 8 mod 10, so generally what is our equation? A is equal to Q into N plus R. So here A will be -8. So I need to find Q, where this is 10 and this should be R. I need to find it. So if I take this as -1, if I take -20, if I take -2, it will be -20. I need to add more value. For example, if I take -20, what it will be? -2, it will be -20. So if I want to minus get, I need to add +12. Now is 1, 2, that is 12 is in the residue set of 10? No, it is not in the residue set of 10. So I cannot take it as 2. Now what I'll do is, I'll take -8 equal to -1. I can take into 10 plus what value? If I what value it will become -8 is, if I add 2, it will become -8. So -8 will be equal to -8. So right, so I residue will be 2. So similarly we can say that 2 mod 10 is equal to 2 mod 10 equal to 2, 12 mod 10 equal to 2, 22 mod 10 equal to 2. So if I take Z10, it has from 0 to 9. And if you say that minus 8 is congruent equivalent to 2 is congruent equivalent to 12, congruent equivalent to 22 with respect to mod 10. And how I am going to represent this congruence relation is like this. Now, we'll also have a concept called as residue class. We also have a concept called as residue class. So, which class of values are called as residue class is if you consider a mod n value, if you consider a mod n, so what are the values of x? What are the values of x that are producing the same residue? What are the values of x producing the same residue y? Consider if you take the mod operation on n, if all the values that are x values that are producing the same residue y on mod n, they're all taken into mod, they are taken into residue class y. They're all taken into residue class y. Okay, so which values are taking as residue class? Again, I'm saying if you consider you are taking x mod n, if you are taking x mod n, and it is producing a residue y, it is producing a residue y. Now, for all those values which are producing, for all those values which are producing of x, which are producing y residue on mod n, those all values will be taken as a residue class of y. Residue class of y. Now, if we consider that mod n as mod 5, so how many residue classes I can have is how many residues I can generate. For n, how many residues I can generate? For n value, I can generate around, right, around 0 to n minus 1, 0 to n minus 1, right, 0 to n minus 1, that is 0, 1, 2, 3, 4. These 0, 1, 2, 3, 4 will be my residue classes. So I will have 5 residue classes. So if I take n equal to 10, I'll have 10 residue classes, that is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now, what are the values that are giving residue 0? They all comes under 0 class. What are the values that are giving residue 1? They all come under 1 class. All the values that are producing residue 2 with respect to mod 5, they'll come under class 2. Similarly for class 3 and class 4. And for class 4, these are called as residue classes. Well, these are called as what? Residue classes. Now we'll see about operations that we can do, or that we can do on modular arithmetic or Zn. Modular arithmetic or Zn. So similarly, the operations that we are seeing in Z, addition, subtraction, multiplication, division we doesn't consider here. So in modular arithmetic, we can do 3 operations basically: addition, subtraction and multiplication. Addition, subtraction and multiplication. So we can basically these operations are done in 2 steps. Basically these operations are done in 2 steps. So in the first step, we will take 2 operands A and B, and we apply the binary operation, and we'll get a value resultant of this binary operation. To that resultant binary operation value, we'll apply the mod with respect to the n value, and now we'll get n residue. Thus residue will belongs to the residue set of Zn. Why? Because if you apply mod with n, compulsory the residue will be between 0 to n minus 1. Those values are represented by using residue set Zn. So this is about addition operation, this is about subtraction, and this is about multiplication. So remember, so we will do in 2 steps. In the first step, we are going to apply the binary operation between 2 integers, and we'll get a result here. The result will apply the mod n operation, and we'll get the residue. We'll get the residue. Now let us check how this works on. So let us find some 8 plus 10. 8 plus 10 mod 5. Now, how are we going to do? First, we are going to apply the binary operation on 8 and 10. So the binary operation is plus, so it will be 18. It will be 18 mod 5. So when we divide 18 by 5, the residue is 3. The residue is 3, right? So similarly, if I take 8 minus 10 mod 5, 8 minus 10 mod 5. So this is minus 2 mod 5. This is what? Minus 2 mod 5. So this will be also 3. This will also 3. Okay. Like that, we'll apply the operations in residue on the modular arithmetic by using different binary operations. So how many different binary operations we are using? Only 3 binary operations: addition, subtraction, multiplication. So we'll see some more examples. Now if I consider I am getting 14 plus 7. I'm getting 14 plus 7 mod 15. So I told first we'll do this binary operation. First we'll do this binary operation. So this binary operation, if you do it, is 21 mod 15. So the residue is 6. 7 minus 11. 7 minus 11. So it is minus 4. So minus 4 mod 13. It is 9. It is 9. So simply want to get add how much value we need to add to get 13. That will be that. So if it is 4, consider this as positive part as 4. How much value I need to add to get 13? I need to add 9. So it is 13. It is 13, right? So 7 into 11 is 77 mod 20. So the residue is 17. How? So 20 into 3, 60. So the remaining value is 17. We'll get it as residue. Now we can apply some properties on these operations. We can apply some properties on this operation. So what are the properties we can apply? We have said that first we'll do the binary operation and then we'll do the mod operation. So what happens? So initially we are doing an integer arithmetic, then we are applying a modular arithmetic. So two different operations we are doing now. So to overcome this one, we can apply these properties, 3 properties, and we can apply only modular arithmetic. So what does the property says is, if you consider a plus b, if you consider a plus b mod n, we consider a plus b mod n. Now it will be same equivalent to a mod n plus b mod n. Okay, so whatever the value you are getting, this total divided by mod n. Similarly, with if you apply subtraction, if you apply multiplication, similarly with the same 3 operations, we can call it as some distributive thing. We are distributing the mod operation, right? We'll check with this example. Okay, so initially we have 14 plus 7. Now we'll consider it as, we'll apply the first property. This is this property. So it is 14 mod 15 plus 7 mod 15. So whatever the value we are getting now, to the whole value we need to apply the mod. So to the whole value, again we need to apply the mod 15. Now if you take what is 14 mod 5, it will give the residue as 14 plus what is the value of 7 mod 5? 7, right? This mod 5. So this is 21 mod 15, which is equivalent to 6, right? We got the same value. Right? So when we apply like this, we got the same value. Like with the other 2 also, that is with subtraction as well as with the multiplication also. Now we can represent in the form of a flow diagram, right? So if you see this flow diagram, this is how generally the process happens. So we'll take the 2 values, we'll take the 2 operands, we'll apply arithmetic operation between them. Now we'll get an output value. For this output value, we're going to apply mod operation with respect to the modulo n with respect to n. Now we'll get the answer. Now, for how we have modified this is, instead of applying the arithmetic operation, now we are taking the modulo arithmetic. Now we'll take A, we'll apply the mod with respect to n. We'll take B, we'll apply mod with respect to n. Now we'll get a residue A mod n, when we get residue for B mod n. Now we'll apply whatever the operation, either it is addition, subtraction, or multiplication. For the value, again we're applying the mod operation, and then we'll finally get the answer. So this is how, by applying these three properties, we can find the solution. By applying these properties, we can find the solution. Now we are going to see the next concept called as inverses. We call as what? Inverses. So in modular arithmetic, generally we'll have two inverses. One is additive inverse and the other one is multiplicative inverse. Additive inverse and multiplicative inverse. So we can say that two values A and B are additive inverse. Two values A and B as additive inverse. That is, we can say that A have B as additive inverse when this property satisfies. When A plus B is congruent equivalent to 0. When A plus B is congruent equivalent to 0, when we are applying with mod n. A plus B is mod n. Okay, A plus B is congruent equivalent to 0, not normal 0. They should be producing residue 0. They should be producing residue 0 with respect to mod n. So the sum of this A plus B should be equal to n. Should be always equal to n. Then we can say that these two are, A is additive inverse of B, or B is additive inverse of A. So this property we can say that A plus B is equal to n. You can say that A plus B equal to n. Right? You can say A plus B equal to n. Or if we modify this equation, we can say that B equal to n minus A. Why? Because you will be given A and you will be given n. You need to find B. Right? So we'll see one example. If you want to find additive inverse of 4 in Z10. So what is our A value? A is equal to 4. What is our B value? B is the value that we need to find out. B is the value we need to find out. And we are given n is equal to 10. Now we can apply the formula. B is equal to n minus A. B is equal to n minus A. So what is the n value? 10 minus 4. So this will be 6. So now we can say that 6 is the additive inverse of 4 and vice versa. We can also say vice versa. 4 is the additive inverse of 6. So each number has an additive inverse and the inverse is unique. Each value has an additive inverse and it is unique. Each number has only one additive inverse. Each number has only one additive inverse, right? So when we are going to say two values A comma B as additive inverse is if A plus B is congruent equal to 0 mod n. That is, they produce the sum of those two values produce a residue of 0 with respect to